In this session, I'll be explaining internal computational fluid dynamics and give live demonstration on internal incompressible CFD analysis of flow inside pipe, nozzle and ducted fan. The fluid flowing between two stationary parallel plates as shown in figure A is an example for internal flow. In internal CFD analysis, the fluid flow within walls or stationary plates form its domain. The domain is represented by horizontal external walls of two stationary parallel plates as shown in figure B. Now, I will give live demonstration on internal incompressible CFD analysis of flow inside pipe using SimScale. To open SimScale software, go to browser or Microsoft Edge and enter web address as simscale.com. SimScale is a cloud software where you can carry out your simulations using laptops, tablets or Android phones without need of any powerful computers. Next, go to Dashboard, create new project, enter your project title here. I'll give the title of the project as Flow Inside Pipe. You can describe your project in your own words. I'll give description as internal incompressible CFD analysis. Select category as aerospace and click on create project. Here you enter into the interface of SimScale software. First step is to import geometry to carry out your analysis. For that, click on the plus icon in geometries. Click on import from computer. Select your model or geometry. Click on import. This is the geometry of pipe for our analysis. In internal CFD analysis, for this problem, the fluid flow inside the pipe, the walls of this pipe itself form its domain. Therefore, there is no need to create domain for this problem. This completes the pre-processing step. Let's start the second step, that is solver execution step, by creating simulation. To create simulation, click on create simulation, select incompressible, click on create simulation. Next, assign materials. For that, click on the plus icon in materials, select water, apply, keep the same default values for kinematic viscosity and density, save. In initial conditions, keep the same values, save. Next, assign boundary conditions. For that, click on the plus icon, select velocity inlet, enter the velocity. I'll give 40 meters per second. Select the phase for the inlet. I'll select this phase and save it. Next, add pressure outlet. enter gauge pressure, select the outlet face, save it. Next, in advanced concepts, I'll keep the same default values for numerics, save. Simulation control, I'll keep the same default values here, save it. Next step is to create mesh. To create mesh, click on mesh. I'll keep the same default values here. To generate it, click on generate. It will take some time. The mesh generation step is completed. As you can see, the mesh generated on the pipe geometry. After the mesh generation step is done, the final step is to run the simulation. Next, to run the simulation, click on the plus icon in simulation runs. Then click on start. The simulation process to complete takes some time. After the simulation is completed, the solver execution step completes. The last step of analysis is post-processing step. To start the post-processing step, click on post-process results. Here we have parts color. Here you can choose pressure, velocity, and turbulent kinematic energy, kinematic viscosity, any of these. Here I'll select pressure. So this is the pressure counter. This is the pressure counter plot for our pipe geometry. Next, add cutting plane. Here you can change the orientation to X, Y, Z axis. And here also you can select any of these. I'll select the velocity magnitude. To view the streamlines of the fluid flow inside the pipe, add particle trace, right click, show all, click on the inlet phase of the pipe. You can increase the horizontal and vertical seats. So I'll give 15, 15. In particle color, give solid color. Select translucent surfaces with wireframe. Now you can view the streamlines from the inlet to the outlet of the pipe. So from the inlet to the outlet, you can view the streamlines of the fluid flow inside the pipe. You can also animate the streamlines. For that, add animation. Select particle trace and play. Right click, show all, select surfaces with wireframe, disable the particle trace, right click, show all, now click on statistics, select the inlet of the pipe. Here you can see the minimum and maximum pressure values for the inlet face of the pipe. The minimum pressure and the maximum pressure. Next, click on the outlet of your pipe geometry. For this, also you can see what is the minimum pressure and maximum pressure value, surface area. This completes the analysis of flow inside the pipe. With this, I will end up this session here. Thank you.